it's really important to learn these derivatives. The derivative of sine x is cos x. I'm not going to prove it in this video. The derivative of cos x is minus sine x. If you forget which ones are negative, look at the first letter. The only ones with a negative derivative are the ones that start with a c. And derivative of tan x is sec squared x. Now this one, these two, sine x and cos x, we're not going to need to know the proof, although I will link a video so you can watch it. Derivative of tan is sec squared. We do need to prove that, so I'll prove that now. So derivative of tan x, we're going to differentiate tan x. Now we know from C2 that tan x is sine x over cos x. And we know from C3 that we can use the quotient rule. So the quotient rule says that the derivative of u divided by v is v times the derivative of u minus u times the derivative of v over v squared. So in this case our u is sine x and our v is cos x. So the derivative is going to be cos x times the derivative of sine x, which is cos x, minus sine x, times the derivative of cos x, which is minus sine x, because it starts with a c, and all divided by the bottom, the v squared cos squared x. So what have we got? Cos squared x minus plus even sine squared x over cos squared x. The top is 1, you know that from C2. 1 over cos squared x, that's just sec squared x. Done. Next 3 to learn, sec, cosec, cot. Now 2 of these start with a c, cot and cosec, so both of those are going to have negative derivatives and sec is going to have a positive derivative. Okay, these are slightly harder to learn, so just write them out a billion times. Derivative of sec is sec tan, sec x, tan x. Derivative of cosec is minus cosec cot, cosec x, cot x. Derivative of cot is minus cosec squared. We do need to know the proof of those 3. So similar to the proof of tan, let's do one at a time. Derivative of sec x. Well, sec x is 1 over cos x. I can actually do this in 2 ways. First of all, I'll do it using the quotient rule. U over v differentiates to v times the derivative of u minus u times the derivative of v over v squared. In this case, u is 1 and v is cos x. So we get cos x times the derivative of 1, which is 0, minus 1 times the derivative of cos x, which is minus sine x, all over the bottom squared cos squared x. So this is sine x over cos squared x, which is, if I make 2 fractions out of that times together, got sine, actually I'll put the sine in the other one. I'll put the sine x in that one, not that it particularly matters. Got 1 times sine x on the top, cos x times cos x on the bottom, and altogether that gives us sec x and then tan x. So that's one way of proving it, and we can also prove it a different way, which I'll do as well to show you. Put that one there. We can do it like this. The derivative of sec x is the derivative of 1 over cos x, which is the derivative of cos x to the minus 1. Now instead of using the quotient rule, I can use the chain rule. So the minus 1 can come down and change to a minus 2. Minus 1 cos x to the minus 2. And then the chain rule says that we have to multiply by the derivative of this thing inside. And the derivative of cos x is minus sine x. So what we get is the minus and the minus cancel, and we've got a sine x, and on the bottom we've got cos x squared because of the power of minus 2, and then we're back up to this step here, and then we can split it into 2 fractions and get sec tan. So there's 2 different ways of doing it: quotient rule or chain rule. Okay, cosec x, we'll do it again, both ways. Derivative of cosec x is the derivative of 1 over sine x. I'm going to use the quotient rule first. U over v differentiates to v du minus u dv over v squared. So we get v sine x times the derivative of 1, which is 0, minus 1 times the derivative of sine x, which is cos x, all over the bottom squared, which is minus cos x over sine squared x, which is making two fractions out of it, minus sine x times sine x, and I'll put the cos x in that one and the 1 there, 1 times cos x on the top, giving us minus cosec x cot x. That's one way of doing it. And we can also do it using the chain rule, as I did with sec, so I'll do that as well now. Put that there. So d by dx cosec x is d by dx 1 over sine x, which I'm going to interpret as d by dx sine x all to the minus 1. So my minus 1 can come down here and change to a minus 2, and then the chain rule says we have to multiply by the derivative of the inside. So let's do that. So the minus 1 comes down, there's the sine x, changes to a minus 2, then we multiply by the derivative of sine x, which is cos x, and then have a look what we've got. We've got minus cos x on the top, and on the bottom sine squared x, and that's the same as we had there. So then we can split it into two fractions and we get the minus cosec cot. And now the derivative of cot x. Well, two ways of doing it. Actually, two ways? Yeah, two ways of doing this. Cot is tan upside down, so cos x on the top and sine x on the bottom. So, first of all, I'm going to interpret this as a quotient. Use the quotient rule, v du minus u dv over v squared. Our u is cos x and our v is sine x. So we get sine x on the top times the derivative of cos x, which is minus sine x, then minus, then u, which is cos x, times the derivative of the bottom, derivative of sine x is cos x, all over the bottom squared, sine squared x. So on the top we've got minus sine squared x minus cos squared x, all over sine squared x, and I can pull out that minus sign on the top there, sine squared x plus cos squared x, that's just 1, we know that from C2, over sine squared x, so that's minus 1 over sine squared x, which is minus 1 over sine x squared, which is minus cos x squared. Done. That's one way of doing it, quotient rule. And the other way is to use the, well, actually this way is going to be more complicated, but I'll show you anyway because it's fun. Okay, put that one there. So this is the other way of doing it. Instead of thinking of cot x as, well, it is cos x over sine x, but instead of thinking of that as a fraction, I'll rewrite it as a product, cos x times sine x to the minus 1. So now I've got a product, u times v, and the derivative of uv from the product rule is v du plus u dv. One of them stays still while you differentiate the other one, and then plus, and then the other way around. So let's start with differentiating. Well, let's do it the easy way around. Let's keep the sine x to the minus 1 still. That can wait while we differentiate cos. Derivative of cos is minus sine. That was easy. Then plus. Right, now the cos x has to wait while we differentiate the sine x to the minus 1. Now this is chain rule within product rule now, because to differentiate sine x to the minus 1, the minus 1 will come down, change to a minus 2, and then we're going to multiply by the derivative of the inside to compensate. So use brackets so it doesn't get messy. The minus 1 comes down, there's the sine x, and the minus 1, the power, goes down to minus 2. Then we have to multiply by the derivative of sine x, which is cos x. That's the chain rule within the product rule. Okay, let's have a look what we've got. We've got minus sine x over sine x. We've got plus, this is not looking good, cos squared x, that's that one and that one, over sine squared x. Oh no, I think this is going to be okay. Here's my, for a minute there I thought I'd gone wrong, but I don't think I have. There's my sine squared x underneath, and there's one of my cos x's, and there's the other cos x. Oh, I've forgotten my minus. That's a minus. There, I think that's right. Okay, we've got minus 1 minus, Now, cos x over sine x is cot x. So this is cot squared x, which is minus brackets 1 plus cot squared x, and using our trig formulae, I think we know something about that. Sine squared x plus cos squared x equals 1. If I divide everything by sine squared x over sine squared x over sine squared x, then we get 1 plus cot squared x is cos x squared x. You probably already know that by now. So here, instead of having minus 1 plus cot squared x, we could say that that is minus cos x squared x. Derivative of cot is minus cos x squared. That way was harder, I admit, but it was more fun. These three don't need any proof, but I'll just put them on anyway so that we've got all the derivatives we need. Derivative of e to the x is e to the x, derivative of ln x is 1 over x, and the derivative of x to the n is n x to the n minus 1. So, in summary, derivative of sine is cos, derivative of cos is minus sine, derivative of tan is sec squared, derivative of sec is sec tan, derivative of cosec is minus cosec cot, derivative of cot is minus, I'm writing equals, I shouldn't be doing, cosec squared, derivative of e to the x is e to the x, derivative of ln x is 1 over x, derivative of x to the n is n x to the n minus 1. All of these equals are a complete lie, aren't they, apart from e to the x equals e to the x. I don't mean equals. I can't even bear how wrong that is. Sin x, I'll use an arrow, meaning differentiates to. Sin x differentiates to cos x differentiates to minus sin x, tan x differentiates to sec squared x, sec x differentiates to sec x tan x, cosec x differentiates to minus cosec x cot x differentiates to minus cosec squared x, e to the x doesn't change, differentiates to e to the x, ln x differentiates to 1 over x, and x to the n differentiates to n x to the n minus 1, and you need to write that out a billion times until you know it.